we're just gonna treat this like a stream. We're just gonna go for it. Okay. I'm making a tutorial on spinning blades. This is what it looks like. I'm gonna pop out using F8. You can see a spinning blade pop in, and there's 6 of them. Now if I walk over to an enemy, it's gonna kill one guy, and then I just killed another guy. Alright, first thing is, let's talk about how I think about this kind of project. First thing is, I think about what blocks are there that I need to work with. So, for one, the player character has to spawn the blades. And next we have a spinning blade attack, and then the blades. These are all the components of this feature. Now, I can move this box anywhere that I want. I can put it in here, I can make something else, have a different system, then call into the blades. I can do whatever. The reason why I've set it up in the way that I set it up for this tutorial, which is I have my own actor for spinning blade attack and then my own actors for blades, is because I don't want the code for the spinning blade attack to be clogging up the player character. For example, I could put all this code in here and just say, within the player character, just run a few functions to do a spinning blade attack within the player character. Now the problem is going to be that if I want an AI to then do this attack, I'm going to have to rip all that code from the player character into the AI, or worse, duplicate it. So I don't want to do all that. I just want to have my own little module here, which is going to be the spinning blade attack actor, and then it's going to spawn spinning blades, and then the player character is going to spawn a spinning blade attack, and that's going to be the only time that the player character actually needs to know about this spinning blade attack actor. Now, I'm going to hop into Unreal and talk about some data editing, and you don't actually have to do any of this. This is kind of just something that I do out of personal preference. It makes it a lot easier for me to go back and edit property values whenever I need to, or if I want to give this spinning blade actor to someone else, I can tell them, hey, it's really easy to edit all of the properties in here. That's what I'm going to start with. Here I have this BP called spinning blades properties, and you create this by doing blueprint class primary data asset. Then you create it, and once you create it, you get a empty blueprint. And I've added all of these variables in here to define what I think spinning blade properties should be. And this also just helps me out with the designing process of, what do I want these spinning blades to actually be able to do. And I've split this up into two different categories, and you can change the categories in here. I just typed out blades, and I typed out spawner. So I want the blades to have a certain amount of damage. I have it, and all these values here are going to be defaults. I have the damage at 25, I have the tick rate at 0.1. We'll talk about the tick rate in a second. Pretty much it means that if an AI is inside of the spinning blade, every 0.1 seconds it's going to do 25 points of damage. And then the spin rate is going to be literally how fast is the blade spinning. It's just a visual thing. The spawn count is how many blades we want at the start of the spinning blade attack. Then the class is going to be what spinning blades are actually going to be spawned. This is nice because we have the spinning blade attack, but say we want not that blade, we want a magic blade or a fire blade or whatever, we can swap out the blade class really easily right here. And then the spinning blade's radius is going to be how far the blades are actually positioned away from the player. Let's see. Now, we have this BP. If I right click and say data asset, click this one right here, I'm going to see BP spinning blades properties. And if I click that I'm going to be able to create a data asset like this, and it's going to be this red block. And now I can actually change the properties however I want very easily. And if I want to then say, hey, I want the defaults back, I just click all these back. And this is going to be very helpful in a second when I go through all of the code for the spinning blades. The first thing I'm going to do is let's take a look at the spinning blade itself. I have this cylinder mesh that is going to represent the collision. So with a lot of attacks, we don't actually want the attack mesh itself to be the exact thing that you're colliding with. For example, in here, a blade is not exactly what you want to be colliding with. It's going to be more optimized and just simpler to deal with a cylinder collision because it's spinning so fast, it's just pretty much a cylinder anyways. So I'm going to be representing the collision as a cylinder. Now we don't actually want the cylinder to appear in game, so I'm going to set this to hidden in game false. By the way, I should probably go through every single detail. I add this component by clicking add here, and then there's actually one for cylinder already, and that's what I did. And I scaled the cylinder to whatever I wanted it to be. So back to this, I set it to it is true, it is hidden game, so we're not going to see the cylinder. I could even go one step further and say it's not visible, which means I don't even see it in this viewport. So I'm just going to leave it like that. And then I have this cube here, and this is going to represent our actual blade. And, oh, actually, sorry, I'm getting ahead of myself. Back in cylinder, we want the collision settings to be different, because this is actually what the AI are going to be colliding with. We are going to set it to say we don't want the character to be able to step on it, and the collision presets to overlap all dynamic. You'll see here that there's a bunch of different collision responses. The important one I believe here is going to be pawn, because the AI are going to be pawns and we want the pawns to be overlapped. But this collision preset overlap all dynamic is going to handle all this for us because as you'll see in a little bit, the overlaps are all handled using or the damage is all handled using overlaps. And I believe that's it for this collision cylinder. Probably also just rename it collision cylinder, and I'll rename this to blade mesh. And now in our blade mesh, we're actually going to do the opposite. So I scaled this cube to be whatever I wanted it to be, and then down here, we still don't want the character to be able to step on it, but we want this to actually have no collision, because remember, the blade isn't going to be the thing that's determining the damage. It's going to be this cylinder, this collision. So this blade, don't want it to have any collision. We're not going to worry about it right now. Now let's step into the event graph. Although what I'm thinking I'm going to show you right now is let's hold off on all of this part. So I'm just going to show you how it works first without any of the blades connected. So let's pretend right now that all we did is create a blade mesh and we haven't hooked up any code yet for any damage. So right now all we have is a blade. The next thing is that I'm going to create an actor, and that's the same thing that I would have done with the spinning blade. It's just an actor. And now we want to create the actual attack itself. And this is, I say attack, but pretty much it's just a blade spawner, but it's going to be useful for carrying the blades around as well. So it's just going to be an actor, and in here, spinning blades attack, let's talk about what it looks like, which right now is actually completely empty. It's just a spawner, so it doesn't actually have to look like anything. Let's step into the event graph to talk about what this does. And this is where the bulk of the code is, and this is where things can start to get a little bit confusing. So let's talk about what we want here. We want to have a spawner that then spawns blades around the player in perfectly spaced out increments in a circle. Actually, let me just show you right now what this is going to look like. I have it on a little bit of a timer. So we want it to spawn these blades out in this perfectly spaced out circle. How are we going to do that? First, we need to worry about spawning the blades, and then we want to be able to add a new blade whenever we want and have that then update the rest of the blade positions, because whenever you add a new blade, you can see all the other blades actually do move. So we're going to have to update all the positions when a new blade is added. And I think that's actually the bulk of it. The code itself gets a little bit more complicated, but we'll take it step by step. The first thing is I just want to spawn an initial set of blades, and that's this right here. And you'll see it's a little bit loopy, and that's because every second we want this blade to spawn, and then we're going to want to come back and spawn another blade if the amount of blades that we've already spawned is less than the amount of blades that we want to spawn. So we'll talk about this array here in a second, but first, this is where the properties variable starts to come up first. Here I have this properties variable, and I created it by it is the type of the BP properties that we created. Again, you don't have to do this. If you wanted to, you could just have a spawn count integer variable in here instead of properties, and every time you'll see properties, you'll see a different variable popped out of it. You can just use a variable in its place instead of using this properties data asset, but I like to use the properties, so we'll go with it. BP spinning blades property object reference, and if I right click, this is actually a shortcut to go back and forth between arrays or single objects. I think I accidentally misclicked. No, I didn't. So this new variable here, you'll see you can select BP spinning blades properties. That's the red data asset that you will have created, and that's exactly how I have this properties variable set up. And I like to split it up into a configs default category and a runtime category, because when people work with it, I want people to know that the configs are what you'll probably be changing, whereas the runtime variables are things that you'll never need to change. So let's go back to this. We're saying we're getting the amount of blades that we want to spawn from this properties data asset. We're saying here it actually tells us the default, which is 6, and we're going to go through, spawn a blade, check if the amount of blades that we've already spawned is less than a count, and then if it is, then we need to go back, wait a second, spawn another blade. You might be asking, like, why am I not just using a for loop and putting a delay in here? This actually doesn't work because this delay node is a latent node, which means it completes, as the note says here, at a later time, but the for loop isn't actually going to do that. It's going to go to the delay, and then since it's delaying, it will actually just go back to the for loop, execute the next element, and then keep going and actually just completely finish pretty much immediately and not do the delay how you think it would work. So we actually need to loop back around and connect it like this. Now let's talk about the spawn blades, and you'll start to see where this spawn blades array comes in. Spawn blade is pretty simple. We just want to spawn an actor, and in this properties here, we grab the blade class, spawn that blade class actor. The transform isn't really going to matter here because in a second we're going to update the positions of the blades. So I'm just saying we're getting the transform of this, which is the blade's actor attack, and that's where the blade is going to be spawned. The owner and the instigator of the blade is going to be the same as the blade attack, and we'll see that in a second when I show you how the blade's attack is actually spawned. Next thing is, once we've spawned in this actor, we want to keep track of it, because actually I think the only reason we need to keep track of it is for updating the position. Otherwise, it kind of doesn't really matter. It can just exist on its own. But I've created this array down here of actors, and I've added this new spawned blade to this array of actors, and then we are attaching this newly spawned actor to this blade's attack. And this is how I'm going to keep track of all the blades. So it's not actually attached to the player. The blades are attached to this attack actor, and then this attack actor is attached to the player. And this makes it a little bit easier for just being able to move this attack actor around. Say you just wanted to place this blade's attack, and not have it parented to anything, you can, and you'll just have some spinning blades, maybe as a trap in the level, something like that. And then we want to, after we've spawned the blade, we need to update the existing blade positions. And this is going to go through and, let me just make sure I didn't miss anything. Yes. Update existing blade positions. We're going to go through all the blades, and remember, we just added this new blade to this array, so it is going to be included. And we need to put it in the correct location around in a circle. And this is where I created this get blade position node. And this node, you'll see it looks a little bit different. This is because I made it a pure node. If you click on the function block right here and then click pure, it's going to make it pure. And what this means is there's no execution pin that needs to go through it. What I use it for is anytime you just need to get a variable, you don't need to have an extra execution pin. It kind of just makes things a little bit nicer. There's a lot of other things, nuances to it, but for now I'll just talk about it as if you want to get a value, you can use a pure node. This is probably where I'm going to have to talk about some maths. So when you spawn these blades, it needs to be in a circle around the player. And let's bring up paint. I think I've worked on this a little bit. Let's see here. There we go. Yeah. So we have this point right here in the middle. We're saying that this is the spinning blades attack actor, and we want blades to be spawned around this actor. And how I'm setting it up is I want there first to always be a blade in front of the player. So that's going to be the initial position, like 0.0. And then every new one is going to be added at some place after 0.0. First, we need to figure out what direction is this going to be spawned in. And this is actually really easy for us because we just want it to be spawned directly in front of us. So there's this node called getActorForwardVector, and that's going to be the forward direction that this actor is facing. Now, we have this. We want to then spawn the next two. So how do we do that? We have this forward vector, and we actually just need to rotate it some amount of degrees to then get to this point, and then rotate it again some amount of degrees to get to this point. And to be clear, we're not actually rotating the actor, we're doing some math on the direction. So say you have the direction, we're facing north, and we just want to know what the direction is 30 degrees around us, and then another 30 degrees around us. Actually, in this case, it's going to be 120 degrees, and then 120 degrees. So we're facing north, we want 120 degrees counterclockwise, and then 120 degrees counterclockwise. this is what we're doing, and there's actually a really nice node in Unreal to be able to do that for us. What we're literally doing is just rotating a vector around another vector. So uh, if we have this vector forward and we want to move it around, we move it around a up vector because we're facing forward and we need to rotate it. It rotates around up. If we had it to the left, we would actually spawn the blades vertically, right? So if we're rotating around this left vector, you could actually have the blade spawn around you like this, but we want it to spawn horizontally around us, so we're rotating around an up vector. And let me just show you what this looks like so far in Unreal. We have the actor forward vector, and we want to rotate this vector around an axis, which is our up vector, remember? And then we want to rotate it some amount of degrees. So you're already seeing how we're constructing a circle. We have this direction, we spawn one, we rotate it, spawn one, rotate it, spawn one. Now we'll talk about how to get the degrees in a bit, but let's talk about how to get this final position. Right now, back to Paint, when you use get actor forward vector, we're saying like north, but we're not saying how far north. And Unreal is just going to default it to literally 1 unit. So it's going to be this tiny little vector forward. So we need to actually extend the vector. And the way that you do that is you can multiply a vector, multiply any direction by a number, and it's going to increase the length of that vector. And since the length of this vector provided by Unreal to us is 1, multiplying it by any number, by some radius, is going to actually make it the length of that radius. And that's exactly what we're doing here. We are multiplying back to Unreal. We are getting the spinning blades radius. We have that rotated vector, and we are multiplying it by this radius in order to make the vector the size of the radius. Now we're saying, so here the spinning blades is unit 100. We're saying we want to spawn this blade 100 units north. Now we have this plus get actor location. All we've done so far is say the direction. Bring up Paint again. All we said is the direction. We're just saying we want this blade to be spawned 100 units north. 100 units north of what? Right? We want it to be in reference to another object. In this case, the spinning blade's actor itself. So we just have to add that location, because right now we're saying it's just up 100 units, from where. And if we don't actually specify anything, it's just going to guess the 0, 0 position, and it's going to spawn the blade like way out over here instead of properly in front of us. So we need to add the get actor location, and that's how we provide a starting point. So we have a starting point, and then we have the vector forward. We move it here, and now we have successfully found the exact point that we want to spawn our blade at. And then when we rotate some amount of degrees, we're going to rotate, multiply by the length, add again to the position. Now we're saying it's going to be, a little bit southwest of us, 100 units, and now southeast of us, 100 units. Let's take a look at how we get the degrees here. So this is just a little bit of geometry. A circle has 360 degrees, and we need to spawn it at certain positions in a circle. And it's going to be based on the amount of blades that we already have. So if you only want to spawn one blade, it doesn't really matter, right? It's going to be at position 0, 0 degrees. If you have 2 blades, where do you spawn that second blade? Because we know that first one's at 0. The second one, just by logic, we want it to spawn on the opposite side of us, which is going to be 180 degrees. And to find that number, we do 360 divided by the length of the blades, which is 2, to get 180. So we have that first one is at 0, and then the next one is 180 degrees away from it. And then by proxy, it's 180 degrees from the star. Now with 3, 120 degrees, it's going to, again, first point at 0, 120 degrees is going to be then the second one, and then 120 degrees is going to be the third one. And this magic node here handles all that actual math for us to do the rotation. So all we have to provide for it is the number of degrees. Now you might be saying, like, how do we know, is it the first one, the second one, or the third one that we need to spawn? And that's where I provide this blade index. So in update existing blade positions function, in this for each loop, we have this array index, and it tells us, is it 0, 1, 2, whatever. I provide this in here, I give it an input, give it an output. The input here is that blade index, we're saying at 0, it's that first position, but there's 3, 120 degrees is the next one, 240 degrees is going to be the third one. And then after doing all that math, we, again, going through it again, we get that rotated vector, we make it the length that we want it to, and then we give it the position to start at, and then that's the exact position where that blade needs to be spawned. I should say, where that blade should exist, because it's already been spawned. Now we just set the blade's location to that position. And that's about it. That, was a little bit of a tangent into math. Apologies for that. I'm sure that there's a few other tutorials that can help with getting doing some geometry with circles a little bit better than I can. And I think that's it for the spinning blade attack itself. So now we actually just need to spawn the spinning blades. I have it here in this shooter character. By the way, I don't know if I mentioned this. This is starter content from the from like when you just create a game in Unreal. You can select the starter content and you can select different templates. This is just the I believe it's the first person template. So and it's all super default. I've barely done anything in here, so you don't actually need to worry about your project not working out with this. If you have the ability to apply damage and you have something to spawn, a place to spawn these blades, then it's going to work. And that's what we're doing here. In this shooter character, which is going to be my player character, in begin play, just delay a little bit. I'm actually going to remove this now because I don't need to worry about it. And then spawn the spinning blades attack. Say the owner and the instigator is the player. And then attach the actor to itself. And here the rules don't really matter too much. The location rule is going to snap it to the correct position. The rotation rule is going to snap it to the correct rotation. The scale rule means that it's going to, this keep world here means it's going to, no matter what size the player is, the spinning blades attack is going to maintain the same scale. The reason why I say it doesn't matter is because get actor transform is actually going to provide these exact same things. But say if I were to spawn this spinning blades attack at like 0, 0, 0 or whatever position, snap to target is going to be what I want because it's going to snap it to the exact position that I want it to be on player. And let me go back to spinning blades attack. I think I might have so make sure to do the same thing when you're doing the spinning blades attack. I think the only one that matters here is the rotation rule. It doesn't actually matter that much because it's going to, they're going to be spinning anyway, so you can't really see. But if you don't set this rotation rule to snap to target, then it's going to be at kind of random rotations based on if like where the player is facing. Now, let's go to, I think that's it. That's it, at least for showing the spawning. Yeah, because they're not spinning yet. So this is what you'll get at this point. Now we want to set up the spinning blades to actually do damage and spin. Let's do spin first because it's easy. Same thing that we did in the spinning blades attack. We need the properties here in order to introduce the properties that we've already created. We have the spin rate here, so I can easily make it spin faster or slower. And there's a nice add actor world rotation node on tick. I'm just going to rotate it on Z. So roll is this way, pitch is this way. We want it to rotate yaw around the up axis. So this is going to handle that rotation very nicely. Now, let's think about how we want this actor to do damage to enemies. We can't just have it so that if the enemy walks into it, it does damage and that's it. We need, like, what if the enemy is standing inside the blades, right? We need the damage to be done over time and looping, right? If you're just standing in there, it's gonna keep hurting you and keep hurting you. And that's what a timer is good for. So if I just right click and do set timer by event, we're gonna see a few different parameters here. Time is gonna be how often this executes. So if I say this timer, it's gonna be how often this event is executed, to be clear. So in 1 second, this event is going to happen, and this event can be directly connected to any custom event. Right click custom event node that you create. Now, if we want it to loop, we need to check off looping. So now it's going to say every 1 second it's going to do this custom event. And then max once per frame. It matters in some cases. In here, it kind of does matter. So say this is at 0.25, and say that you lagged for a whole second. So nothing happened in your game for a whole second. There are 4 times that this timer should have happened, right? At 0.25 seconds, at 0.5 seconds, at 0.75 seconds, and at 1 second. So it missed 3. It would execute once, but it's gonna miss 3 different executions. Max once per frame, if you check it off to be true, means that it's only gonna execute once. If I click it off, it means that it's gonna see that it should have executed 4 times and do all 4 of those times. And that's what I'm gonna set it to, because what I'm imagining is that if you're lagging and that enemy has been in your blades for a long time, it should probably, kill them instead of just doing 1 execution of damage. And you'll see this create event node here. I could just directly connect this custom event, but I like the create event node just because it makes it a little bit less messy. It's just create event, and you'll see I can connect it right here, and then I select the function that I already created. So I select do damage, and it does the same thing. It's just a little bit cleaner. Also, it means that I can actually connect it to functions instead of having to have everything in events. And actually, this one can be a function instead of an event, so I'm going to move it. But first, actually, let me just show you the trick to turning an event into a function. Right click it, convert event to function, has become a function. Now our event graph is a little bit cleaner, and all of our code is in this do damage function. By the way, you might see me pressing a button to clean up everything all at once. And this is a plugin called Blueprint Assist. I'm not affiliated with it at all. Go support that creator. They're awesome. This plugin is absolutely amazing. You just do whatever, move whatever, and then press F to clean up your blueprint. Anyways, back to what we were talking about. Every damage tick rate, which is every 0.1 seconds, I want to do damage. And in this do damage, I'm checking the overlapping actors. Remember, I have this collision setting to be overlap all dynamic in its collision presets, overlap all dynamic. I am grabbing the damage that I want to do from the properties. Again, don't have to set up the properties, just make it a variable if you want it, if you want to, but I like it this way. And then I'm using this apply damage node. This exists already in Unreal, regardless of starter content. So it is just going to apply damage to the actor that you want to be damaged. In here, we're getting all the overlapping actors. I want that to be the damaged actor. I want the damage to be the base damage. And then the instigator and the causer are going to be the instigator and causer of this actor. So the instigator and the causer are going to be connected to, back here in the shooter character, I set it to self, is the owner and instigator of the blade's attack. The blade's attack then passes its owner and instigator to the blades itself. So that's how the blades know that the player is its instigator and its owner. Actually, the owner doesn't matter here. It's just the instigator. And then the damage causer is going to be self, because the blades are actually doing the damage, not necessarily the player, but the player is the one instigating the damage. And then I have a print string here just to make sure that we actually applied some damage. You know, this is completely optional. And that's it. And here in Get Overlapping Actors, there's a class filter, so you can specify what types of actors, what types of classes you want to actually get in this overlapping actors. And in this case, I only need to check for pawns, so I check for pawns. It's best to check for the smallest amount possible, so I don't really want to check every single actor. I just want to check for pawns. And I believe that at this point I have connected up everything. So if I go back to here, my blade should be spinning. They'll be spawning every second. And these AI dudes are doing some stuff. Oh my gosh. So I just killed them, and you can see that it printed. You'll see that at one point it printed none. At the actually very last print is none, and that's because at the point when the spinning blade's attack does its final amount of damage, it actually kills the enemy. So the damaged actor here that I'm printing out is going to be none. You know what? Let me actually show you how to set up this format text print, because it's actually super helpful and not really clear at the start. So first, it's just a regular print string node, and then if I use format text, this is a really nice node that lets you print things really nicely. If you put anything within brackets, it shows up as a variable. So if I want to say damage, it's probably what I should be naming it instead of just D, or enemy actor. It shows up as gray pins, and this means that it'll try to interpret the pin however it can, and not all pins can be turned into text. So an int can easily be turned into text, so it turns it into text like this. Same thing with actors. Actors have a function to turn their name into text, so it easily interprets that. And now it'll print out damage and enemy actor, and I can add whatever text I want to before or after it, or like, you know, between the brackets, but inside the brackets it's going to take from the pins that you put in. And I think that is actually it. So if you want to move this code to a different actor, all you have to do is change, just move this part. So in this shooter character, I am, spawning and attaching the blades. Just disconnect it, move it wherever you want, and then that's now that thing can do a spinning blades attack. Uh, yeah. Let me know if I can help out with anything else. Uh, give me feedback on this tutorial, please. I think that I would like to make more tutorials. I think it's fun. I want to make some random content as well. Uh, yeah. Have a nice day.